Hi, I'm Professor Goins. In this video, I'm going to take a look at some basic summation formulas that you will use when you work with Riemann sums. Okay, first example. So I've got three summation formulas that I want to talk through, and then we'll put it together and do an example of an evaluation. First, look at the following. If I have 1/2 plus 1/2, that equals, of course, 2 over 2, which is 1. If I have a third plus a third plus a third, that would be 3/3, which is 1. We can generalize this as follows. If I have the summation of a value, let's say 1 over n, and I range that from k is equal to 1 to n, so that I have whatever this value is right here, I've got, say, 1/3, I'm going to have 3 of those. If this is 1/4, I'm going to go have 4 of those. Therefore, that summation value is 1. Because in this case here, your n would be 3, and your k would range from 1 to 3. So it'd have a third plus a third plus a third, which is 3/3. Okay, next basic summation formula. Let's motivate it with the following example. If I take, say, 1 plus 2 plus 3 plus 4 plus 5, let's say that's some number n that we don't know yet. Well, another way to generate n is to reverse the order, since addition is commutative, and I can write this as 5 plus 4 plus 3 plus 2 plus 1, so just in the opposite direction. That value, of course, will also be n. And I could have this to be 1 through 1 plus 2 up to 5,000, and then I can just reverse the order, and they'll still add up to the same number. Now what I want to do is add this vertically. Notice what I get. 1 plus 5 would be 6. 2 and 4 would be 6. 3 and 3 is 6. 4 and 2 is 6, 5 and 1 is 6, and an n would be 2n. Okay, then what I'm going to do is notice I've got how many 6s? I've got 1, 2, 3, 4, 5. That would be 5 times 6 is equal to 2 times n, and therefore the value of n would be 5 times 6 over 2. Which would, of course, be 15, but the idea is I want to look for the pattern. And if I was to add, like I said, 1 through, say, 5,000, okay, so what's the pattern there? Well, the pattern is the value of n is going to be the product of 5, which is the number, how many terms I'm adding up, times 1 more than that, and then over 2. Meaning, if I was to add up, say, 1 through, let's say I go back to this and I put plus dot, 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 and I make this go up to, let's just say 50. And then over here, this would be 50 plus dot, 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 all the way down to 4, 3, 2, 1. Then my summation, the value of n would be 50 times 51 over 2. We can generalize that to the following formula. If I add up the first n positive integer, so let's say I'm going to say from k equals 1 up to n of k. In other words, if n was 50, this would be 1 plus 2 plus 3 up to 50. The pattern that we observed is it's going to be how many terms I'm adding, which would be n, multiplied by 1 more, which would be n plus 1, and then over 2. This one is used pretty frequently, and again, we'll have that in our example here in a moment. The third formula that I want to talk through is, well, what if I have the situation where I'm adding up the same number? Sort of like I had here, but this was, fractions. Here I'm adding up, let's just say, and it could be any integer for any number of terms. Here, if I added up, say, 1/3, I want to do it 3 times. Or if I wanted to do 1/4, I would do it 4 times. But here, I'm adding up the same number any number of times. First example, I've got 4 plus 4, so let's see how many 4s do I have here. 1, 2, 3, 4, 5, 6. That means this would summarize to 4 times 6. Here I've got 7, 7, 7, 7, so I've got 4 7s, so it would be 7 times 4. In other words, what I have is the number that I am repeating and then how many, right? This is just multiplication that you learned in a previous, elementary school, really. And so the general formula is the following. If I take the sum from k equals 1 up to n of just any constant, well, it's just the constant times how many I'm adding. So this would be the constant, which plays the role of either the 4 or the 7, multiplied by n, n is how many I have. Okay. So we're going to use, I guess not this one, but we'll use this one and this one to evaluate this summation. Okay. To evaluate this summation, we can use properties of sums, that the sum of the sum is the sum of the sums. Meaning, I can separate this as follows. Okay. It always sounds confusing when you hear it for the first time. So let me read this again. This is a summation and this is a sum. So maybe let me use the word summation as opposed to sum. The summation of the sum is the sum of the summations. Okay. A lot of times in class we like to say it as the sum of the sum is the sum of the sums, just because it sounds funny. But again, it's the summation of the sum is the sum of the summations. Okay. And then what I can do with this series right here, or this finite series, I can take a constant multiple and I can pull it out front, giving me, let me put it down here, this would be equal to 3 times the sum k equals 1 to 10 of k. Notice this expression here is this expression here, and then I have plus the sum from k equals 1 to 10 of 2. And then let's use our formulas that we just talked through. This would be 3 times, well, the sum of the first 10 positive integers, so 1 plus 2 plus 3 plus 4 up to adding to 10. Well, all I have to do is I take the how many numbers I'm adding, which is 10 of them, multiply by one more than that, divide by 2. This would give you then 10 times 11 divided by 2. And then over here, this summation is this formula. I'm adding up 10 2's. So that would be 2 times 10. And then evaluate. Let's see, 10 over 2 would be a 5. And then that would be 5 times 11. This gives me 3 times 5 times 11 plus 2 times 10, which is 20. 5 and 11 would be 55. So that would be 3 times 55 plus 20. 3 and 55 would be 165. So this would be 165 and 20, which would be 185. Okay. There's some other basic summation formulas that we can go over, but just so this video isn't super long, I'll put those in a second video. But these are the 3 introductory summation formulas that you will see in your Calc 2 class.